Welcome, you have made it now to session C, where we gonna help you to understand and modify OpenFOAM or parts of OpenFOAM. What I will do now is to introduce some basic C and C++ concepts to you. In the first task, we're gonna create a type definition and make a small program with you, so that helps you to understand how to use C++ in the context of OpenFOAM. In the second part, we're gonna build an application. This we will call the mesh inspector. We will start from a template that is supplied by OpenFOAM. And third, we're gonna write a library that can be used to linked to an OpenFOAM application. And this is we're gonna call scalar transport advanced. This will be a function object that we can link to any OpenFOAM solver. Before we go into the details of these tutorials, let us start with some basic C++. We're gonna have a look at the slides of Håkon Nilsson, which are very, very good, just a few slides. First of all, what is of course important, if you're working with OpenFOAM source code, you need to know that this is compiled. So please always check if the code that you have been implementing is compiled and you're using actually it, because a lot of errors originate from using different applications or libraries that you have not modified. So let us have a brief look on these slides 1 to 8 of Håkon Nilsson. I have opened them for you. They are of course supplied also with this video in the package. Our aim is now to basically understand what the source code means, and that we're also able to modify some parts of the source code. You will see later in these 3 examples what this can be of use. C basic types, float, double. I don't go into the details. If you don't know about this, I suggest you to take a basic C++ tutorial that introduces you these variables. Include files, we're going to have a look later at this, and also the path to libraries. This is standard essentially for when you're compiling code. We're going to have a look at this later. Key thing is that in OpenFOAM we are working with object orientation. This is a very important concept that underlines C++, and yeah, this is very useful. I think you can easily read this. This is not very deeply connected to OpenFOAM. What is very often used, and this is also very much confusing for a lot of people, are pointers. Yeah, so pointers are essentially they point to the memory location where an object is residing, and you generate a pointer simply by using this command in C++. You can also generate a new object and return the pointer with such a command. We're going to use that later. If you have pointers, the syntax of calling so-called member functions of objects is slightly different. Remember this. If you have the object, like this is called name object, you access the member function with dot, and if you have a pointer to an object, you access it with this syntax here. What is important, of course, are definitions and declarations of the classes. This should be always separated in different files. This is also common C++ stuff. Here are some details related to definitions and declarations. So please put them in separate files. If you have a lot of inline functions, then put them also in a separate file. For example, if you have a header vector.h and you have an implementation vector.c, and you would like to have a lot of inline functions, then please put it in a separate file that is then called vector i.h. Yes. What a constructor is should also be already known. You should understand this from basic C++ concepts. It's not OpenFOAM specific. Good. What is also important for you is that OpenFOAM heavily templating, so you should know about templates. If you don't know about this yet, then please make you familiar with it. Good, that's it for this introduction. We're next gonna start with this task number 1, as indicated here. We're gonna make a small program in C++ that works with OpenFOAM. Okay, see you soon.